Hello everybody, we are Alon Tal and Omry Dabush and we are presenting you our Java project. In our project, we have used the BFS algorithm to generate our maze. Let's briefly review the pseudocode of the BFS algorithm. We have the priority queue, which is called open and contains all the possible moves. And we have the close set that will hold the all position we have visited in. While our priority queue is not empty, we will pop from the priority queue the best first state and we will add it to the close set. If the state is the goal state, we will backtrace all of our previous state which are located in the close set. If the state is not the goal state, we will develop all possible moves for this specific state and then we will check for each possible move if we haven't visited that state at all. If so, we will update the state we came from to the possible move and finally we will put it the open priority queue. Otherwise, if there are cheaper way to reach the next move, we will update its cost in the open priority queue. In our project, we will never reach the otherwise state because we cannot get to the same state from different paths. In A-star algorithm, the main difference between BFS and A-star is that A-star is given a cost to each move, and because for each state there is a different cost, we can reach the goal state in much more efficient way.
In the server app folder, there is no file of mazes that has been generated. Now we'll run our application to demonstrate how it works. First, we will launch our graphic user interface. As you can see, we added a simple maze layout of the original due date of the project. Now we will generate a 3D maze. Let's use 3 layers of 15 by 15 maze. As you can see, you can move freely throughout the maze and we incorporated sound to each valid move the player takes. For example, if we press left, the sound is generated, but if we press up, no sound has generated. If you look carefully, you could see 2 arrows indicating if you can go up to the upper level or down to the lower level. The arrow will turn on and off depending on your location in the maze. Let's open another GUI at the same time and choose a different settings to the maze. Now we will open our server that can solve our mazes. To activate our server, we need to type the command open the server. And now the server will keep listening to any new clients that will address it. Let's go back to one of our mazes and let's request a hint that will help us solve the maze. Once we have requested a hint, the server received the request and immediately sent the result to our maze. And now the player has moved one step closer to the exit of the maze. Notice that we can do this as many times as we want until the player has reached the exit of the maze. Let's do this again, but now we will request a full solution of the maze from the server. See what happens. As you can see, the arrow and hint solve button has been grayed out because they are no longer relevant. As you can see, the player is moving between our 3 layers of different mazes to the exit. Now we'll demonstrate our proper exit from the maze and from the server. First, let's close one of the mazes by clicking on the X button. As you can see, the window is closed and there are no threads running anymore. We will do the same thing in our second maze, but we will use the App Exit button from the drop menu. And finally, we will close the server. With the command close the server. And the server closes by not accepting any new thread and waiting until all existing threads are finished. And last but not least, let's open our lib folder. And as you can see, there is a new maze.zip file that saves the last mazes that has been generated. Architecture, which uses 3 different layers: model, presenter, and view. In this architecture, the presenter layer will extend the observer class, which observes any observable for any changes that occur. And the model and view layers will be observable types, which means that each one can notify their observer that something has changed, the presenter in our case. Let's demonstrate how the layers communicate with each other. First, let's go to our GUI class, which is a type of view layers, and see the code of the generate button. As you can see, once the button has been clicked, the class raises a flag that something has changed and notify the presenter of the change with a proper command. In the presenter layer, the update method receives a notification from the view layer and forward the request to the model layer. In the model layer, which is responsible for all calculation methods, start the maze generate command, and at the end notify the presenter that the task has been completed. And once more, the presenter will transfer a proper message to the view layer. The server side works in the same architecture patterns of MVP, while the only command that the server knows is open the server and close the server. Those commands are a part of a view layer which runs on a separate thread. When we type open the server, the command is then transferred to the presenter and then to the model. In the model, we create a thread pool which can handle a fixed number of clients. Once the open command reaches the model, a new thread is opened and the server awaits until new clients' requests are received. In the model package, there are handle client class, which is responsible for the client request. In our client handler class, we can handle two types of requests: solve, which calculates the solution for the maze with our solving algorithm, and get solution, which searches the wanted solution in a hash map of solution. This particular request is for the command line interface. To demonstrate our communication method between the server and the client, we will explain how the data is transferred from the client to the server and the other way around. On the client side, the data is being transferred like so. First, we create an array list of objects, and the data that we send to the server is based on the array list. In each segment of the array list, we will enter a different type of object. For example, the first segment, we will enter a string with a client request. And in the second segment, we will enter the solving algorithm. And finally, on the third segment, we will put the maze ready object. In case that the request is sending from the middle of the maze, we will receive a fourth segment, which represents the position of the player. On the server side, the data is being read in the same way that it has been packed into the solving algorithm. The result of the solving algorithm is being transferred as an output string. Finally, when we type the command close the server will perform a shutdown process, but before doing so, it will save every maze and solution that the server solved, using an existing library called gzip output stream.